linear equations and polynomials.
Oh, we are done with both the chapters already, right?
Yes, ma'am.
Let's start real numbers.
Oh, ma'am, I can't see you or your screen. Okay, now I can see.
Okay. We are going to start the discussion from real numbers. Now you should, when you will see this real number, you will be able to understand it's that real number which we were talking about in the previous class also. We have already discussed about the rational number. We have already discussed about the irrational numbers. Okay, and we were saying that natural number, rational number, irrational number, whole number, natural number, integers, everything are just real number, and the diagram looked like this one, that we are having natural number, the counting number which starts from 1, then we are having whole number. Okay, all the natural number, and 0 also, whole number starts from 0. After that we were having integers, that means whole number, natural numbers. Okay, but we are also having positive numbers, negative number. These number with positive or negative sign are called integers. Okay, so that also you already know, you have seen. Then we were having rational numbers, and we said that any number which is in the form of p by q is called rational number. Okay, where q must not be 0. All this number, integer, whole number, natural number, are rational number, but apart from that, any number in the form of p by q, fractional numbers, are also rational number. Now we said that there are number which is not rational, which is irrational, which are irrationals. And the example of irrational were √2, √3, √5. Again, we will be talking about this type of numbers, and everything all together, everything is called real numbers. So the name of this chapter is real number. That means we are going to talk about these numbers, and in detail we will be understanding few theorems are there. So we will see what the theorem says, what the rule says. However, we have used whatever the theorem, whatever the concept is there in this chapter, we have already used unknowingly from your lower classes. You have used those concepts. Okay, here we will be understanding it. Now these all are real number. So you must be thinking, why we have to say it's real number? Is there any number which is not real? Yes, there are numbers which are not real. That's why always we will specify that we are talking about real number. When you will go in higher class, you will see that few numbers are there which are not real, and those numbers are called imaginary number. So mathematicians has found that the number which are not real number are called imaginary number. And what is imaginary number? Whenever inside the square root we are having a negative number, be it a -1, be it a -2, be it a -25, be it a -3, inside the square root if we are having negative, that's called imaginary number. Okay, so that's why here we are going to talk about real number. That means for all the number which exist in this universe are called real number. The number which we can write in our copy by using the digits 0 to 9, be it a fractional number, be it a decimal number, be it a terminating decimal, non-terminating decimal, whatever number you can think of, all are real number. Imaginary number are something which is just in imagine, and these are like this type of cases, we call it imaginary number. So let's get back to track that Rational number, we have done the discussion of rational number, and we said that the number which is in the form of p by q, where the denominator q should not be 0, is called rational number. Now I have explained that the denominator 0 is not acceptable in mathematics. Whenever the denominator is 0 of any number, 2 by 0, 3 by 0, x by 0, y by 0, x plus y by 0, this is not acceptable in mathematics. This is called not defined in mathematics. So there are two cases which we always avoid in mathematics. One is denominator should not be 0. Another is negative term inside the square root. Negative term inside the square root. These two are the cases which is called not defined, which we always try to avoid. Okay, these are some extra information. However, we are going to stick to our discussion of real number. Real number. Every time we have to mention it because few numbers are there which are not real. Okay. So first thing first, we will be talking about composite number here. Then we will be discussing about prime numbers. So can you tell me, Arya is there, Ifra is there, Shadin is there, Sumaya is there, Aisha, you are also here. What is composite number?
Numbers which have factors more than one and its number, and that number itself.
Yeah, which have more factors than the number itself and one. Okay. Yes, the number, any number, like if we are taking a number 12, we can say factors. If we want to write the factors of 12, factors of 12 can be 1 and the number itself. These two we always include whenever we are writing the list of factors of any number. 1 and the number itself we always write. But apart from that, we check if there is any other number which is the factor of this 12. So can you let me know, anyone from here, what are the factors of 12 apart from 1 and 12?
3,
2, 3, 6, 4,
2,
2 also. So these are the factors of 12. Okay, whenever we are listing down the factors, that time we think that which number can divide 12 completely. 2 can divide 12 completely, so 2 is a factor. 3 can divide 12 completely, 3 is a factor of 12. 4 can also divide 12 completely, so 4 is a factor. 5 cannot divide 12 completely. 6 also can divide 12 completely, so 6 is also a factor. After that, 7, 8, 9, 10, 11, these numbers cannot divide 12 completely. These are not the factors of 12. The number itself, 12 is factor of itself. Okay, so whenever we are listing down the factor of any number, 1 and the number itself, we always write. So what is the definition of composite number? If any number is having more than two factor, those numbers are called composite number. More than 2 factor. But why more than 2 factor? Because 2, when we are talking about 2 very basic factor, that is 1 and the number itself. 1 means this one. 1 and the number itself, these are the 2 factor. Each and every number will be having 1 and the number itself, these 2 factor. If any number is having more than these 2 factor, more than 2 factors, then those numbers are called composite numbers. Already known to you, just I am helping you to recall this concept because we will be using it again and again over here. What about prime numbers? Anyone?
Numbers that are divisible by itself.
Just a second. No? Yes, prime numbers. Anyone was saying about prime number? Please let me know again.
Numbers that are divisible by itself.
Number that is just divisible by itself are called prime number. Yes, perfect. Or we can also say the number which has exactly two factor, just two factor. That also one of the way of saying it. So the number, if we try to list down the factor of 17, we can see only 1 can divide 17 completely and 17 can divide 17 completely. These two are the only factor of 17. No other factors are there. Hence, 17 is a prime number. Similarly, 23, if we will write, only 1 can divide 23 completely and 23 can divide 23 completely. So, these two are just the factor of 23. Okay. So, these are the example of prime number. Composite number and prime number we have already discussed over here. Now there is a theorem which is called fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Let me write the theorem over here as it is, the way it is given in your book. As it is, I am going to just copy paste the theorem over here. Then we will try to understand what does the theorem says. Because when it is in written form in the, like the theorem, once I am going to write it, it will not be that clear, but we will understand it in detail. Just a moment. So the theorem says that I want to write the statement over here as it is, then we will see what exactly the theorem says. So the theorem says that every composite number can be expressed as product of primes, and this factorization is unique apart from the order in which the prime factorization prime factors occurs. Okay, let's see what exactly this theorem says. First, we will try to understand the theorem. So here it says that every composite number, now only we have discussed that what is composite number. So it says that every composite number, let's take few composite number. So the example of composite number can be 12. Example of composite number can be 24 as well. Please do the factorization of 12 and 24 and please let me know what are we going to get. First, factorize 12. Okay, please do the factorization of 12 and let me know what are you getting. Yes.
Teacher, 2 into 2 into 3 for 12.
2 into 2 into 3. Perfect. This is how we can factorize 12, right? Now, if we will try factorizing this 24, what are we going to get?
2 into 2, 2 cube into 3.
2 cube into 3, that means 2 into 2 into 2 into 3. Perfect. Let's see what the theorem says. It says that every composite number can be expressed. Every composite number can be expressed as product of primes. So we have taken two composite number. These two are composite number, okay? If these two numbers are having more than two factors, these two are the example of composite number. Here, the fundamental theorem of arithmetic says that every composite number can be expressed as a product of prime. Is it so? Yes. We can see that one of the composite number 12 we have taken and we are able to write it as a product of prime number. 2 is a prime number. 3 is also a prime number. Okay, 3 is also a prime number. So every composite number can be expressed as a product of prime. This much is clear to us. Yes, we have taken two composite number and we have checked. We are getting the product of primes only. Yes, that is applicable for every composite number. So, okay. So every composite number can be expressed as a product of prime. This much, the underlined part is clear to us. What about the next? And this factorization is unique. It says that the theorem says that this factorization and the yellow underlined part says that this factorization is unique. Unique means if you will take 2 into 2 into 3, if you will take 2 into 2 into 3, you will be able to generate this number 12 only. All of sudden, when you will take 2 into 2 into 3, you won't be able to generate any other number. You won't be able to generate 32. You won't be able to generate 100. You won't be able to generate any other number apart from 12. So whenever you will take this factorization, this prime factorization, product of prime factorization, 2 into 2 into 3, one and only one number you will get in result, that is 12. It is unique for 12. Yes, along with this, if you will add one more number by yourself, be it a 5, be it one more 2, be it 3, then you will get another number. But with the combination of 2 into 2 into 3, you will get just 12. That's why here the word unique is mentioned, that every composite number can be expressed as a product of prime, and this factorization is unique. This factorization, whatever you have got, this is unique. This is one and only one. This will generate one and only one result, that is 12 only. Similarly, for the other example also, we can see the composite number we have represented as a product of prime, and this numbers, the combination of 2 into 2 into 2 into 3 can only generate 24. It will never ever generate any other number multiplied together. Are you getting me? Are you getting it?
Yes, ma'am.
Okay, that's what the definition says. The factorization is unique for the given number apart from the order in which the prime factors occur. The factorization is unique, but the order is not unique. Order you can change here and there. This 3 you can write at first and then you can write this 2 into 2. Order you can shuffle, you can do here and there, that is okay. Order is not unique. Order can be here and there. Maybe Arya is saying that we are getting 2 into 2 into 3. Aisha is saying that no, we are getting 3 into 2 into 2. Ifra is saying that no, like again 2 times 2 is there, so even if we will shuffle it, we will be getting 2. Or Ifra is saying that we are getting 2 into 3 into 2. So you can see everyone is talking about the same numbers, but the orders are here and there, and that is completely fine. Recall that commutative property you have learned, and in that commutative property your teacher has must explain that 3 plus 2 and 2 plus 3 is the same thing. Okay, minus 3 plus 2 and plus 2 minus 3 is still the same thing. Both the number are just commuting here and there with its own sign, obviously with its own sign. Even if it will come here, it will come here, the result will be same. That the same applicable for the product also. 3 into 4 and 4 into 3 is the same thing. That's what the theorem says, that the factorization is unique. With this combination, you will get one and only one number. But the order is not unique. Order can be here and there. Let's summarize everything. Here, fundamental theorem of arithmetic says that every composite number can be expressed as a product of prime. Yes, we have seen that. We will be taking any composite number and we can express that as a product of prime numbers. Okay, and this factorization is unique. That means whatever you are getting the factorization, the product of few number, with that combination of number multiplied together will generate only that number. Okay, the way we have discussed over here, that 2 into 2 into 3 will generate 12 only. It will never ever generate any other number. Or 3 into 2 into 2 will generate 12 only. It will not generate any other number. This number is unique. Okay, the factorization which we have got for this number, it is unique. The same factorization, I cannot say that we will be taking any other number 15 and that will also give the factorization 2 into 2 into 3. That is not possible. This factorization is unique. Okay, only 12 can give this factorization. No other number can give this factorization. Yes, along with this number, if suppose I am taking another example, that is 36, that can be written as 2 into 2 into 3 into 3. So along with this, all one more extra number, if we are multiplying, then we are getting the other number. But these factorization 2 into 2 into 3, this is only for number 12. That's why the terminology factorization is unique, is written over here, but order is not unique. Apart from the order, that means this unique word is applicable for factorization only. It is not applicable for the order. Order can be here and there. We can shuffle the number here and there, commutative property. Still, it's the same thing. Is it clear to everyone?
Yes, ma'am.
This fundamental
Yes,
theorem of
ma'am.
arithmetic is clear. So
Yes,
when
ma'am.
you will read this theorem in one go from your NCRT, every composite number can be expressed as a product of prime number, and this factorization is unique apart from the order in which the prime factor occurs. It will just become tangent from our head, and it will not just, even nobody will be able to like understand it in detail what exactly this theorem says. This is how in your book everywhere you will find in mathematics the theorem, the concept is explained. However, if you will sit with it, if you will try to break the sentences and will read it, I always say my student, even if you are having solving the word problem, please break the word problem. Just read few first sentence at first and think about it, what it is trying to say, what it is trying to convey. If you have understood that part, then go to the next part. This is how you will be able to understand it. Okay, So fundamental theorem in mathematics, fundamental theorem of arithmetics, this one is clear to you. Now one question is there. Let's solve one question by using this theorem. So the question is, consider the number 4 to the power n, where n is natural number. Check whether there is any value of n for which 4 to the power n ends with the digit 0. We will try to understand this question first. Okay. Before that, first let me know. Yes, one by one, everyone let me know whether the fundamental theorem of arithmetic is clear to you. Yes or no? Aisha?
Yes, sir.
Clear. Abdul? Yes, Abdul, is it clear?
Yes.
Okay. Arya?
Yes, ma'am.
Okay. Ifra,
Yes, ma'am.
Shadin, and Sumaya.
Yes, sir.
Yes, ma'am.
It is clear to everyone. Okay, let's see. What does this question says? First, we will understand the question. Then we will think about solving it. First thing first, what the question says. The question says that consider the number 4 to the power n. Consider there is a number 4 to the power n, where n is a natural number. What is natural number? We know all the counting number which starts from 1 are natural number. So we are having 4 to the power n, where n is a natural number. It can be 4 to the power 1, it can be 4 to the power 2, it can be 4 to the power 3, it can be 4 to the power 4, it can be 4 to the power any natural number. Any natural number can be the exponent of 4. Okay. Check whether there is any value of n. Check what is the exponent of n. What is that natural number? Check it. For which 4 to the power n ends with the digit 0. Check it. What is that exponent which we will be taking so that 4 to the power n will give the result as whatever be the result, that results end the like ones place digit is 0. Okay, 4 to the power end with the digit 0, that means 4 to the power 1 is 4 ending with 4. 4 to the power 2 16 ending with 6. 4 to the power 3 64 ending with 4. 4 to the power 4 256 ending with 6. Similarly, what is that power? What is that n value? When we will take it with 4 to the power n, our result end with digit 0. What is that power of 4? What is that power? What is that n value? Which we will take, and the result will, whatever be the result, that result and the digit will be 0. Are you getting it? Everyone, are you getting it?
Yes, ma'am.
Yes, ma'am.
Yes, rest of the student, are you getting it? What the
Yes,
question
ma'am.
says? Okay, so here we have to search what is that exponent, what is that natural number which is sitting as an exponent of 4 that will generate a result, and that results end digit is 0. that results end digit is 0. Okay. Now, if we can also write this 4 to the power n, law of exponent you have done in previous class. So solution we are going to do. This was just the observation. This was just the observation. We have seen that we have tried to understand the question. That is this was just that part. Solution here we will be doing on our left hand side of the screen. 4 to the power n can be written as 2 to the power 2. 4 can be written as 2 to the power 2 and that power n, right? Can we write it as like this, 4 to the power n?
Yes, ma'am.
Yes, ma'am.
We can write it like this, okay? 2 to the power, if we will apply the law of exponent over here, this will become 2 to the power 2n. We have to multiply the exponent. We have done the multiplication of exponent and 4 to the power n can be written as 2 to the power 2n. Clear so far? Is it clear so far?
Yes, ma'am.
Yes, ma'am.
Okay. We can write it as a 2 to the power 2n. Now when we are taking n value as a 1, this is just for understanding. When we are taking n value as a 1, then this 2 to the power 2n became 2 to the power 2 into 1. That means 2 to the power just 2. That means 2 into 2. Okay. When we are taking n value as a 2, let's say, because n are natural number. So if we are taking n as a 1, it became 2 into 2. If we will be taking n as a 2, then 2 to the power 2n will become 2 to the power 2 into 2. That means 2 to the power 4. That means 2 into 2 into 2 into 2. This is what we are getting when we are taking n as 2. Okay. When we are taking n as 3, we will be getting 2 to the power 2n will become 2 to the power 2 into 3. That means 2 to the power 6 and it will become 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5 and one more 2, 6. So whatever we are going to take n, are you getting the pattern? We will be getting 2 into 2 into 2 into 2 into 2. Just like that, number of time according to the
Yes,
value of
ma'am.
n. Yes or no? We
Yes,
have
ma'am.
to check whether we will be getting 0 as a last digit. When are we going to get 0 as a last digit? That we have to check. Now here I am going to show you one concept which we need to understand to answer this question. Okay, the concept is whenever we are having a number like 10 or maybe 20 or maybe 100, if we will do the factorization of 10, what are we going to get?
2 into 5.
2 into 5. If we will factorize this 20, what are we going to get?
2 into 2 into 5.
2 into 2 into 5. If we will factorize this 100, what are we going to get?
2 into 2 into 2 into 2. Like 2 5 times.
That's it.
No.
Please check
One
it.
minute.
We are not going to get that many times too. Yes, please let me know. Check it. What are we going to get out of
It's
this?
gonna be 2 into 2 into 5 into 5.
It will be 2 into 2 into 5 into 5. Yes, rest of the student, are you getting the same? Aisha, Abdul, Ifra,
Yes.
Shadin, Sumaya. Are you
Yes,
getting
ma'am.
the same?
Yes, ma'am.
Yes. Everyone is getting the same. When we are factorizing this 10, we are getting 2 into 5. When we are factorizing this 20, we are getting 2 into 2 into 5. When we are factorizing this 100, we are getting 2 into 2 into 5 into 5. From here, we are going to make one conclusion that if in our factorization, if there is a number 2 and if there is a number 5, then and only then we will be getting the end digit as a 0. If we are having combination of these two number 2 and 5, apart from this there is extra number, that is fine. Apart from this, if we are having any extra number, that is 2 into 3 into 5. Apart from 2 and 5, if any other extra number is there, that is fine. Still we will be getting the end digit as a 0. But if 2 and 5 is there, then and only then we will be getting the end digit as a 0. Are you getting it? If only 2 is there, we will not be getting end digit as a 0. Never ever we will be getting end digit as a 0 if only 2 is there. Or if the combination of 2 and other number is there, then also the end digit we will not be getting 0. If 2 and 5 is there in our factorization, then that number's end digit will be 0. If you want to check with any number, please tell me, we will be checking it on the screen. Do you want to check for any number? Arya, Aisha, Abdul, Ifra, Shadin, Sumaya. Do you want to check for any number?
No, ma'am.
No,
I
ma'am.
am saying that any number you pick, any number you pick, any random number. If you are picking a number, 6,000, 8,000, 220, any number you are picking, that number's factorization you will do. 2 and 5 obviously will be there. It can be 2 to the power maybe 4, maybe 5, 2 to the power anything, 5 to the power anything. Extra few other numbers are also sitting over there, that is 11, that is other number, that is fine. Okay, if we will be doing, let's do the factorization of these three numbers also quickly. So 220, if we will factorize it, we will be getting 2 into 11 into 5 into 2. This is what we'll be having. If we will arrange it, it will be 2 into 2 into 5 into 11. End digit is 0. I said 2 and 5 will be there. Yes, it is there. End digit is 0. I said obviously 2 and 5 will be there. Let's check it. 6 into 10 to the power 3 I am writing for now, which can be written as 10 to the power 3. We can write it as a 10 into 10 into 10. And this 10 will give 2 into 5. This 10 will also give 2 into 5. This 10 will also give 2 into 5. So we can write it as a 2, this 2, this 2, this 2, and this 2. 4 2s we are having. How many 5s we are having? 1, 2, 3. This 5, and this 5. 3 5s we are having. 1 3 we are also having. So can you see there is a combination of 2 and 5? Can you see? If the end digit is 0, that means 2 and 5 is there. Okay. So let's get back to our question. What we need? We need end digit as a 0. Now can you tell me, anytime are we going to get 2 and 5? 2 to the power 2 and we are having. N equals to 1 we have taken, we got 2 into 2. N equals to 2 we have taken, N equals to 2 we have taken, and we found that we are getting 2 into 2 into 2 into 2. N equals to 3 we have taken, N equals to 3 we have taken, and we are getting 2 into 2 into 2 into 2 into 2 into 2. So whatever n we are going to take, it will just be 2 into 2 into 2 into 2 into 2 into 2 according to the value of n. Yes or no? Yes or no?
Yes. Yes, ma'am.
Are you getting? Aisha,
Yes,
Ifra, Shadin, Sumaya, Abdul,
Yes, ma'am.
everyone is getting?
Yes, ma'am.
Shadin, are you getting?
Yes, ma'am.
Sumaya, are you getting?
Yes, ma'am.
Everyone is getting. Abdul, have you responded? Anything which is not clear? Okay. So we found that whatever we will take as a n, since we are having 2 to the power 2n, n is any number. 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, whatever is the power of 2, eventually we will be having 2 into 2 into 2, whatever be the number of time according to the value of. That means we will only be having 2 over here. We are not going to get 5 over here. Then how we will be having n digit as a 0? Is it possible to get n digit as a 0? End digit as a 0. Is it possible?
No, ma'am.
It is not possible. It is not possible here because the combination of 2 and 5 is required to make the end digit as a 0. Here it is not possible because we have represented our 4 to the power n. I am going to rub this all the part. This was just for understanding. Whatever we are going to take as a value of n. Okay, eventually it will be 2 to the power something which will give only 2's, no 5. And if we don't have any 5, that means end digit will not be 0. Let me write it over here. 2 to the power 2n will not contain 5. Hence, 4 to the power n will not end with or will never end with the digit 0 for any natural number n. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Something we have written on the right hand side with this curly bracket, this curled part which I have just kept it aside, that was just for observation. There also you can see 4 to the power 1 is 4, 4 to the power 2, n digit is 6, 4 to the power 3, n digit is 4, 4 to the power 4, n digit is 6. Can you see it is just repeating the pattern
Will
of
not contain 5
4, 6,
hands.
4. Yeah, what?
Nothing, ma'am.
Can you see it is repeating the pattern of n digit as a 4, 6, 4, 6, 4, 6, 4, 6? Getting it? Let me write 4 to the power 5 also. 6, 4 times 24, 4 carry 2.
Ma'am,
Please
we only
find
have
4
to
to the
write
power 5, no?
this.
Yeah?
We don't have to write anything. Like we only have to write this.
Yeah, we don't have to write this. This is just for understanding.
Only the one in the purple. We have to write that only.
Yeah, we have to write
Okay.
this much. That was just for understanding. Please note it down, everyone.
Ma'am, this applies for every other number also, right?
Yeah, what?
This applies for every other number also.
Yeah. Yes, Arya, what are you saying? I'm not getting. Can you repeat?
Does this apply for every other number also?
Yes. The
Okay.
concept which we are learning here, that whenever we will be having the combination, the product, the factorization of 2 and 5, then and only then the numbers last digit will be 0. It applies to everywhere, not only for this standard, not only for this chapter. Always in mathematics, you take any number. If the end digit is 0, that means the factorization must contain 2 and 5. Okay. If no
Yes, ma'am.
5 is there, if only 2's are there, then you will not get end digit as a 0. If only 555 is there, still you will not be getting the end digit as a 0. Okay. So the combination of these 2 and 5 has to be there. You can understand 2 into 5 is only making 10. And this 10 has to be there to be end digit as a 0. Yes or no? If you will be having 5
Yes,
into
ma'am.
5 into 5, whatever be the number of time, it will not give you 0 as a last digit. Will it give?
No,
Are you
ma'am.
having any example where you can see that only 5 is there, still the end digit, the last digit is 0 of that number?
No, ma'am.
No. So that's what I am explaining. It is applicable. It is logic. It is the logic which we are having. It is applicable for like every time. It is applicable for all the numbers in mathematics. Okay. Here the observation which I was talking about, 4 to the power 1 end digit is 4. 4 to the power 2 end digit is 6. 4 to the power 3 end digit is 4. 4 to the power 4 end digit is 6. And again 4 to the power 5 end digit is 4. Can you see it is 4, 6, 4, 6, 4, 6. It will always be 4, 6. It will never be 0. Okay. Clear?
Yes, ma'am.
That was just the observation. This is the concept, because no 5 is there in the factorization. So how come, like, how can we get 0 as a last digit? That's it. One more question is there. I am giving it to you. Please do try it. Okay. We will be discussing this question in the next class. Let me write the question. It is assertion and reason based question from your previous year question paper. Assertion is 12 to the power n ends with the digit 0 where n is natural number. Reason is any number ends with digit 0 if its prime factor is of the form two to the power m into 5 to the power n, where m and n are natural. Note it down. Okay. We will be talking about this question. We will be discussing this question in the next class. Assertion says that 12 to the power n ends with the digit 0, where n is a natural number. Reason says that any number ends with 0 if its prime factor is of the form this, where m and n are natural number. Options will be there that assertion is correct and reason, assertion and reason both are correct, and reason is supporting the assertion. Option B will be assertion and reason both are correct, but reason is not the correct explanation of the given assertion. Option C will be assertion is correct, reason is false. Option 4 will be assertion is false, reason is correct. You just need to write this one in your notebook. We will be discussing this question. It is based on the previous concept only. We will be, first you try it. We will start our next class with this question. Do write this assertion and reason.
Okay, ma'am.
Written.
Yes, ma'am.
Aisha, have you written?
Yes, ma'am.
Shadin, Sumaya, Ifra,
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Abdul,
Yes.
everyone has noted it down. Please think about it. We will start our next class.